Looking at question number 4. A student was asked to find 98% confidence interval for a widget width using the data from a random sample of n equals 24. Which of the following is the correct interpretation of 14.3 and 33.6? There's a 98% confidence that the mean of the population is between this and this. With 98% confidence, the mean width of a randomly selected widget will be between that and that. There is 98% confidence that the mean of a sample of 24 widgets will be between this and this. The mean width of all widgets is between this and this 98% of the time. We know that this is true because with 98% confidence, the mean widget of all widgets is between 14.3. So this one should be that one right there with 98% confidence. So what we're doing here is we are using this confidence interval to estimate the population mean. So the mean of all widgets, not just the mean of widgets of sample size 24, but the mean of all widgets. It's not that the mean of all widgets is between this 98% of the time. The mean does not change. The population mean is a set value. 98% of the time, our process captures the true mean, but that means we're 98% confident, but the mean doesn't change. Our estimates change, but the mean does not with each new sample, right? And then let's move down for a half second here and do question, I believe the next one was 11, right? Okay, so they're asking on question number 11, it says n is 26, our sample mean was 35, our sample standard deviation was 5, and they want to find the margin of error at an 80% confidence level, all right? So you notice that we're using samples. They did not give us sigma. So this is going to be a t-interval. There's a couple different ways to do this. I'm going to do it all 3 ways for you. First, I'm going to do it by hand. Then I'm going to use the TI-84. And then I'm going to use Minitab. All right. So by hand, and even by hand, I really do need to use some type of technology for that. Because I need to know what my critical value for 80% is. I'll do that just like, so I have a T distribution with n equals 26, so I have degrees of freedom 25. My degrees of freedom is n minus 1. Right. So from here, I now am looking for 80% confidence intervals, these cutoffs, which means that there's 10% here and 10% here. So I am looking for this number right here, which should be negative, or this number right here, which is the positive version of that. This, I would put area as 10% because the left tail has 10%. To get this one, I put area as 90% because the left tail has 90%. So if I'm doing that on my calculator, I would go to my calculator. Right, I would go stats, tests, second distributions, inverse T right here, enter. Once my area, if I put 10%, 0.10, I get my left tail for the negative 1, degrees of freedom 25. Hit enter, I get negative 1.36. We'll go to negative 1.316. So we'll go ahead back here. So our t is negative 1.316. Now if I wanted to use Minitab for that, let me launch Minitab real quick. Let's do it in Chrome. All right, so I can be full screen. So I'm going to go to and log on to Minitab by going to my portal. I'm going to log in. Okay, so I'm at my Minitab here. And I'm going to go to data, calculate probability distributions, inverse. I'm looking for a critical value for 10%. I could also do 90, but not a normal, a t-distribution with 25 degrees of freedom and obviously a zero centrality parameter. And then we can hit enter, and voila, same number pops up right here. Okay, so you can do this both using Minitab or using your TI. Right, so that is my t-value. Now I'm going to find my margin of error. My margin of error is my critical value times my standard deviation divided by the square root of n. Okay, that is my margin of error. So I'm going to take negative 1.316 times 5 divided by the square root of 26. And that I need to do in a calculator. So I'll go over to my calculator again. Shut it. There we go. So I had this answer. So answer times 5 divided by the square root of 26. And I get negative 1.2078. And so this should be margin of error. Now that's the negative because I use negative 1.3. My actual margin of error is going to just be the 1 point, what did I say? 1.29078. So negative 1.290. So just 2 decimal places. There we go. Now I said I would show you how to do this using Minitab and the TI, so let's do that as well. Using the TI, I can just build the confidence interval. So if I go to stat, calculate, test, T interval, which is number 8, enter, and I have summarized stats, and they told me that it was a mean of 35, a standard deviation of 5, a sample size of 26, and a confidence level of 80. And I calculate that. It gives me 33.709, so 33.71, and 36.29. So 33.71 to 30, I don't know why that keeps closing, 36.29. Now if I take one of these problems, subtract the mean from it, either endpoint, that gives me my margin of error. So that's how we can do it doing the TI. Then using Minitab, let's see what we can do using Minitab. So I can go to this stats, basic statistics, one sample T. I think that will give me a confidence interval. Let's find out. Nope, that's not it. I think it is under one sample T. All right, so summarize data. Sample size was 26, sample mean was 35, sample standard deviation was 5. We're not asking to perform a hypothesis test yet. That's the next chapter. Options. Confidence level is 80. Alexa, turn off the timer. And the hypothesized mean, that's what we want, is the equal, not equal. And hit OK. And then hit OK. And voila. All right, so it gives you these things. There's our confidence interval again, the 36.29 and the 33.709. So we still need to do the same thing here that we did with the calculator. Gives us the confidence interval, and we are going to just subtract the mean from that to get the 1.29 to get the margin of error. And that was number 11. Let's take a look at number 17, which is another one. Express the confidence interval in interval form. So they've done all the work for us here already. So here's our point estimate, plus or minus our margin of error. So to express this in interval form, this is number 17, we are going to do 307 plus 133. All right, that's going to give our upper limit. And then we're going to do 330.7 minus 133. And this is going to give us our lower limit. And so this would be interval form, and we would type it in just like that. So you would just take your parentheses and do 197.7, comma, 436.7, and then close your parentheses. And did I subtract wrong? Yep, or no, I didn't subtract wrong. I just entered it in wrong. $63.7. There we go. And that does number 17. The last one I'll do on this video, before I meld them together so they don't get too long, that's what that timer was reminding me, is let's do 24 real quick. You intend to estimate the population mean and the confidence interval. You believe the population to have a normal distribution. Your sample size is 9, right? So it is an uncommon, while it is uncommon confidence level, find the critical value that corresponds to the confidence level of 99.8. All right, so they're just looking for the critical value here. Find the critical value. And they want 99.8%. So here's this guy. Our sample size is 9, so our degrees of freedom is 8. If we have 99.8% in the middle, we have 0.2%, so 0.00, this is, 0.001 over here, and 0.00, is that right? Let's see. We're going to take 1, I'm going to do this on my calculator so I don't mess up this math. 1 minus 0.998, enter, and divide it by 2, 0.001. There we go. All right, so we went 0.001, 0.001. So if I want to get to the positive one, I could put in 0.999 as my confidence interval. I can do that on Minitab or on my calculator. On Minitab, I go to calculate. Calculate. Probability distribution, inverse. T. Degrees of freedom is 8. Value is 0.999. Hit enter. And it's 4.50079. So 4.500, and accurate to 3 decimal places. 007 would be 00879. There we go. Doing it on the calculator, I'll go ahead and show you that as well. You would take second distribution, inverse T number 4, area 0.999, degrees of freedom 8. Hit enter. And we get the same number. All right, hopefully that's helpful. I'm going to put these 2 weird videos together and post them for you right now.